Hi everyone, and welcome to this very important lesson where we again are going to determine the equation of a parabola if we are given the graph. Now this lesson is going to be very important because you are going to learn something completely new. Now if we look at the information given in this graph, we are going to have to try and find the equation by using these three general forms. Now if I look at this graph, you can see that this parabola move to the right because the turning point will be over here. So we will not be able to use this general form because this one does not include left or right movements. This general form, well, the only thing that we can get from a graph is the y-intercept. Now if I go to the y-intercept, we don't have the coordinates for it, so we cannot put anything into C's place. So we cannot use this equation. And we do not have the turning point's coordinates, so we cannot substitute anything into P and Q's place, so we won't be able to use this equation as well. So now what do we do since we cannot use any one of the three that we are so accustomed to? Well, here's the thing for today. When you are given a parabola with two x-intercepts and one other point on the parabola where this point is not the turning point, we are going to use a brand new equation that you are going to have to memorize, and it looks like this. Y is equal to a, and in the first brackets we've got x minus x1, and in the second bracket we've got x minus x2. Now please remember, we only use this equation when these circumstances exist, and I'm going to mention it again. When we are given two x-intercepts and one other point on the parabola, doesn't matter where it is as long as it's not the turning point. Okay, so now let's quickly see what all of this means. Well, this x1 represents one of our x-intercepts. This x2 represents the other x-intercept. And this x and x is the same x-coordinate, and this is the y-coordinate of that other point. Okay, so now let's do substitution of this x1 and x2. So in the place of x1, I'm going to put this x-intercept, which is minus 1, and there it is. And in the place of x2, I'm going to put this x-intercept, which is 7, and there it is. Now this minus 1 becomes a plus 1, and this minus 7 stays minus 7. Now in the place of this x and this x, we are going to put this x coordinate of that other point. So that 4 goes in here and that 4 goes in there. Okay, and in the place of the y, we are going to put this y coordinate, and there it is. And now the only variable left in this equation is a, so if we multiply out these brackets, we're going to get minus 15a, and we've got minus 15 on this side, and to get a, we're going to divide with this coefficient on that side, so minus 15 divided by minus 15 gives us 1, and a is equal to 1. Okay, so now we know what a is, and we can simply go and put this 1 into a's place, and then multiply this out again. So let me show you. So we're going to write y is equal to 1, and then again the same bracket, x minus x1, and in the place of x1 we're going to put this minus 1, there we go, and x minus x2, and in the place of x2 we're going to put the 7, there it is. And now once we multiply all of this out, you will see that in this bracket we are going to get x plus 1, and in this bracket the x minus 7. We do product of two binomials, so first times first is x squared, first times second is a minus 7x, second times first is a plus 1x, and second times second is minus 7, and we still have the 1 at the front. And then it's the distributive law, and we end up with y is equal to x squared minus 6x minus 7. So if you are unfamiliar where the minus 6x comes from, well, minus 7x plus 1x is a minus 6x. And there we go. So we are done. Please remember this, it's very important, and we'll see you again next time. Bye.